Hello. So if you recall last video, we looked at introducing transducers, and I gave a basic example where all we need to do is amplify a signal. And here we're going to look at a slightly more complicated example where we need to amplify but also add a bias. But just by way of review, a transducer is a device that takes an energy of a certain type and quantity and changes that into a different energy of a different type and quantity. Okay, and for this example, we're going to look at a transducer that basically is a thermometer. So it's going to take in the energy, type, and quantity of temperature, which is a physical quantity, and it's going to translate that into this electrical signal, which would go to a display. So you're going to like, oh, it was 10 degrees outside. And you have a display that would tell you that. So that's what we're looking at. So let's just start off by making a big box for this transducer we'll discuss. Okay, and as our input on this side, we're just going to have temperature. And as our output, let's say we're going to have a display that's saying it's 10 degrees out. Ideally, if everything works out and this says 10 degrees, it actually is 10 degrees outside. But in order to feed that display, what we're going to need is what we'll call this V out. And we're going to need a certain voltage corresponding to different temperatures so that this display can read it correctly. And let's just go ahead and write out a table just to show what kind of voltage range that we're going to need here. Okay, so let's say that we are at 0 degrees Celsius. What we'll need in order to display that properly on our display, we'll need a V out of 0 volts. And let's say we're at 100 degrees Celsius, we'll need a V out of 5 volts. So we need to make sure we're getting the right voltage so we display the right temperature up here. And in order to get that, we need to translate this temperature into a voltage. And in order to do that, we can use what's called a thermocouple. And this is a transducer because it's taking this certain physical quantity of temperature and it's translating that into this voltage, this electrical quantity of voltage. So we'll call this V in because that's going to go into our amplifier and bias. All right, so why don't we just connect? We got V in here and we've got, what we know our V out is. Why don't we just, draw a line, connect these together and we're done, right? Well, maybe not that easy because it's not clear that this thermocouple transducer is actually going to output, these exact voltages that the display is going to need to properly read it. And it turns out in this case that when we have 0 degrees Celsius, our thermocouple transducer output, which we call Vn, is going to be 2 millivolts. And at 100 degrees Celsius, this Vn, which is our output of our thermocouple, is going to be 4 millivolts. So our challenge here is to convert this V in to the proper V out so it reads it properly. And the easiest way to do that is first making a table like this and then just translating this table onto a graph, and where we could assume that this V in blue here is our x-axis and this V out is our y-axis. So let's go ahead and draw that out. Okay, so having drawn out our axes here, we can go ahead and just plot these at certain points. So this 0 degrees Celsius, we can just sort of treat as one point on this plot here. So this V in is like our x. We'll go over 2 millivolts here. So we'll call that 0.002. And then we'll go up to 0 volts, which isn't really up at all. It's just going to be right here. So that's our 1 point. Well, I guess we could call it our 0 degrees Celsius point. And then we have our next point here, which is going to be at 100 degrees Celsius. We go over 4 millivolts. So right to here, 0.004, and we'll go up to 5 volts. And that point is going to be right about here-ish, and that corresponds to 100 degrees Celsius. And basically all we need to do here is get a line that connects these two. And that equation for the line that connects these two is essentially going to be how we need to modify our V in to get our V out. So in order to find that, it's probably useful just to look at the equation for a line, which you're probably familiar with from algebra class, y equals mx plus b. So first thing we want to find here is m, that slope, which is pretty easy. If you recall, that's just going to be rise over run. So our rise is going to be right here, and that's just going to be 5. And our run is going to be down here, and that's going to be 0.002. So we can just go ahead and plug those in, 5 over 0.002, and we end up with a fairly large number of 2,500. So first thing we do is find that slope, and then we also need to find b. And in order to find b, we want to use our point slope formula. And perhaps you recall what this is, but the equation is y minus y1 equals m times x minus x1. So we already know what our m is from up here, but what about our x1 and y1? Well, we can pick either of these points. So it's probably easiest in this case to pick 0 degrees Celsius because we have the 0 down here. So we can just pick this as our x1 here, and this is our y1. And we can go ahead and plug these values in for x1 and y1 over here. And plugging that in, we get y equals 2500 times x minus 0.002. And in order to solve for this b here, we just got to multiply that 2500 times that 0.002, and we get our equation that we need, which is y equals 2500x minus 5. Okay, so let's go ahead and take this equation we solved for and just actually sub in v out was our y and our v in was our x. And this is actually going to be the v out that we have up here. And just to give a more general form for this, we're going to use, instead of m for this slope here, we're going to call that k. And instead of little b, we'll call that big B for this minus 5. All right, so this is the equation that we're shooting for, but then that begs the question of kind of how do we symbolize what's happening between, to get from v in here to this v out. And basically, we just need to do two things here. We take that v in and we got to first multiply it by k, and then we got to subtract the b. So multiplying it by k would be represented like this, where our output of this amplifier here is just going to be v in times 2500, our k value. And also we're going to want to subtract b from it. So let's write that down here. Or I should say we're going to add b, because b in our case is negative. And in order to symbolize the addition of these two components, we just have an adder right here, which we'll use the summation symbol for. That gives us our output here. So so you see there's a couple steps here in order to translate from this temperature to this display. First we need this thermocouple to translate that temperature to voltage, and then we need to, in order to translate that to the right voltage that display needs, we went through this process of putting a table, graphing it out, using some basic algebra formulas, and then finally just going through what the proper symbology is to show how these two add to get it. So that is a slightly more complicated example of a transducer. So I hope it was helpful, and until next time, take care.